All right, welcome back. We're now up to section 2.5, and this time we've graphed linear equations. Now what we're going to do is we're going to actually graph linear inequalities. Okay, so one thing we have to kind of pay attention to is if it's greater than or less than, of course, and then if we also have the equal symbol underneath it. So let's kind of show you graphically what we're talking about. When we draw the line where it's equal, that's the line itself. That's where, if you put a number in for x, that's where it's going to equal the y, and when you do that. So that's the line. Now, where is y greater than? Y greater than is going to be above it. Okay, it's going to be above the line. Greater than is above. Less than is going to be below, is what we're going to see there. Okay. Now, again, when we graph these, we're going to have to pay real close attention of whether we want to graph it with a line that is solid or dotted. And we'll get to that in just a second here. So that's kind of what we're talking about here. All right, so here we go. Here's an example. If we're going to graph this, we'd graph it just like we did linear equations. We'd start at 2, and our slope is negative 1/3, so we'd go down 1 and to the right 3. Now, as we draw the line, we have to pay attention. If there's no equal sign, if it's just greater than or just less than, we want to make it dotted. Now, again, greater than would be above, so we're going to shade above the line is what we're going to do. Okay? So that's just a little bit different twist to what we had before. All right, what if we had a y is less than or equal to negative 1? Well, we know that that is a horizontal line at negative 1. Now, we know it's solid because it has the equal sign. That's the key there. Now, less than means we shade below the line. Below the line is right here. Okay, so again, we're going to have that shaded part there as we go. All right, takes a little practice. Not too bad, though. Once we've graphed linear equations, this isn't too bad. All right, once again, we're going to start here at negative 2. That's the y-intercept. The slope is 3, so we'd go up 3. 1, 2, 3, and to the right 1. Now, again, because it has the equal sign, we're going to make a solid line, and greater than would be above the line. Above the line is what we have there. All right. Now, you might get into this thing of, well, I'm not really sure if it's above or below. It's hard to tell. Well, you can always use a test point. The best test point to use is 0, 0. Put 0 in for x and for y. And in this case, what you get is you get 0. Is 0 greater than or equal to? Well, this would be 3 times 0, which is 0, minus 2. Is 0 greater than or equal to negative 2? If it makes a true statement, which this is, then that is indeed the side you'd want to shade on. So you can always use that as a test point. You can use any point that you want to. It's just 0, 0 is really an easy point to use. So feel free to do that. All right. Here we go. Well, what if we graphed using intercepts? Now remember our duck and cover method from before. We would know that the y-intercept would be 3 and the x-intercept would be 4. So let's put those two dots on the graph. And again, paying attention when we connect them, we're going to use a solid line because it's got the equal sign. And then, of course, less than would be below. Again, you can use the test point 0, 0 because, again, you get 0 plus 0 is less than 12. It does work for that test point if you wanted to use that as well. So again, that's the different graphing that we can have for that. We had some practice with those. It's a little built on something that we did before with linear equations. So remember, solid or dotted, based on whether you have the equal sign or not, and then greater than above, less than shade below. Till next time, I'm Mr. Boone.